this tutorial, we're going to go through separating the Blinky and the button logic into two separate threads. So we're going to start from scratch, generating ESP template project. We're going to call this threads, no container, ESP32-C3, latest, STD support. Okay, so we're going to go into threads. And again, we have our default Hello World project. We're going to start by building this project because that'll take a while. Okay, so the first thing we need to do is edit our cargo.toml file. So we're going to update the version of ESP32-C3. We're going to import ESP32-HAL version 0.40.0. We're going to use ESP println. And that's going to be version 0.3.1. Features of ESP32-C3. Then we're going to use some new crates. We're going to use crossbeams, version 0.8. And then we're going to use crossbeam channel, version 0.5. And crossbeam will help us synchronize the threads and send messages back and forth. Okay, so now we need to use our crates. So we're going to use crossbeam channel, called bounded, so that limits the amount of channels. And then we're going to use the ESP32-HAL. We need the peripherals. We need GPIO. We're gonna need a few more things here because we're gonna need to pass generic IO to the functions. So we'll explain all these. So any IO pin, any output pin, IO pin, input, output pin, pin driver, and we need our pull down. Okay, now we're also going to use the delay for RTOS. And that should be it for ESP32-HAL. And then we're going to need to use the ESP println crate for println macro. Okay. And now we're going to start by getting our peripherals. Take the singleton, unwrap it, and then this time we don't need, we'll just make the LED pin not mutable because we're going to pass it into a function. Okay, so driver output, peripherals, pin GPIO 8, and we need to downgrade that output to generic output. I'm going to unwrap it. Okay, then we need to make a mutable button pin. It's going to be pin driver input peripherals pin GPIO 6, and we're just going to downgrade this. You might ask why not downgrade into an input like we did with the LED pin, and that's because the set pull method requires pin be input or output. So that's why we can only downgrade it, and that makes it either an input or an output. Okay, so we unwrap that. Now we got to make our channels. So our RX and TX channel to pass the button state to the Blinky thread. So we're going to say TX RX tuple is bounded 1. So just one channel. Okay, and then we're going to make our two threads. So we need LED Blinky thread. It's going to be of the types. We're going to use the standard library thread builder, and we're going to assign a stack size of, we'll come up here and define a stack size. So this is going to be static Blinky stack size type usize. I'll make it 2000 bytes, which is the minimum. Stack size. Okay. Okay, and then we need to spawn that, and we're going to move. We need a Blinky function, so we call it Blinky thread function. We're going to pass it the LED pin and the RX of the chart. Okay, and so now we can make that thread function. So let's say Blinky thread function, and it's going to take an immutable LED pin of the type pin driver, any output pin, configure it as an output, and then it's going to take the RX of a crossbeam channel. So that's the receiver. And it's going to be a type bool that we pass back and forth if the button is pressed or not. Okay, so now inside of this function, we're going to have to keep track of the Blinky status. So that's going to be mutable, and it's going to keep track of if the Blinky is running or not. Okay, and then we do a forever loop where we're going to try to receive from the RX line, and if we get something, then we're going to set the Blinky status to that value. If we don't get anything, then we're just going to do nothing. Okay, and we're going to say if Blinky status, so if the Blinky is supposed to be blinking, then we're going to do LED pin dot set low on wrap. And again, for my board, setting the pin low turns the LED on. So we're going to print out that we turn the LED on. And then we need to delay, pre-RTOS delay. And we're going to do 1 second delay. And then we're going to turn the LED pin, make the pin high. And for my board, that will turn the LED off. And then we'll print out that we set the LED off. Okay, and then regardless of the Blinky status, then we'll delay again. And we're going to delay again for 1 second. Okay. So all this should compile now. I'm going to build this in the background. ESP print line, okay. So where's our problem here? This thing. Okay. I'll let that build in the background while we do the other thread. Okay, so now we should have our Blinky thread. And now we need to make a button thread. So let button thread. Again, we're going to use the standard library thread builder. And then we need to give it a stack size. And so we can define a new stack size. So let's make this the button stack size. And then we're going to spawn this thread, move ownership move that into the button thread function, where we're going to pass the button pin and the TX line. Okay. Now let's make that button thread function. So we call it button thread function, and we're going to pass in button pin of the type pin driver NEIO pin. It's configured as an input. And we're also going to pass in the TX of crossbeam channel sender of the type bool. Okay. And then we're going to keep track of the button state so we don't continuously spam the other thread with messages if we're holding down the button in one state or another. So make it immutable. Button status equals false. And we're going to loop forever. I'm going to say if button pin is high, and if we're not already button status true, I'm going to set the button status to true. We're going to print to the console that button is on. And then we're going to send a message through our crossbeam channel about the status of the button. Unwrap that. Okay. And then if the button is low, we're going to check if the button status is on already, and if it is currently on, then we're going to turn it off. We're going to print to the console that the button is off, and then we're going to send the status to the Blinky thread. Okay, and at the end of the loop, we're going to do FreeRTOS delay milliseconds, and we'll delay for 100 milliseconds. Okay. Button state. So, okay, so that should be good. And I'm going to do another cargo build, see if we can get rid of all the errors. Okay, cool. ESP flash, TTY.USB, target, RISC-V, debug, and this is going to be threads. Okay, ESP monitor, TTY, USB. Okay, now if I turn the button on, see the button goes on, and Blinky starts and stops. Take it out, the button is off. So, alright, we separated our button and Blinky logic into separate threads, and we're passing a message back and forth. Again, if you have any questions or comments, please leave it below. Thanks.